Okay, so we are adding, subtracting, and multiplying radical expressions. So just so you know, to add or subtract radicals, the inside must match. Okay, the radical must match too. So if it's a square root, they both have to be square roots. It's a cube root, they both have to be cube roots. Yes? Okay, cool. So for example, if I have 2 square root of 3 plus 4 square root of 3, do they have the same root?
Yes.
Do they have the same inside of the root? Yeah. So we can combine this. What's 2 plus 4?
6.
So this would be 6 square root of 3. So an example of something you cannot combine would be 2 square root of 3 plus 3 square root of 2. Do they have the same insides?
No.
Therefore, they cannot combine. Okay? Another thing to remember when it comes to radicals, they're a lot like terms. So if we had 2x plus 3x, what does that equal? No. 5x, add. You're good. Okay, did the x change? No, just the number in front, right? So what if I did 2x times 3x?
Okay, that's
6x squared. So did the x change? Yes, so when you multiply, they can change. Same concept with radicals. When you add or subtract, the radical does not change. Yes? But when you multiply, it does. Okay? So let's get into it. If you look at number 1, we're just multiplying 2 terms with radicals. So what is 3 times 5? Because they're both outside, we can multiply and combine them. And what's 2 times 6? So this is what we get when we multiply. The outside numbers multiply and the inside numbers multiply. However, can this simplify? Yeah, 12 can break down. 2 goes into 12 6 times. 2 goes into 6 3 times. So I can take a 2 out, and what's left over? 3. Bring down your 15. There's no symbol, so this is multiplication. So times 2 root 3. Well, what is 15 times 2? 30. So this is just 30 square root of 3. So if we look at number 2, well, I only have 2 outside numbers. I don't have a second inside number, and that's fine. What's 3 times 5? 15, and then just bring down your root 2 because there was no other square root to combine it with. So there's your answer. So now let's throw some addition in there. So remember, when we're adding and subtracting, they have to have the same root and the insides. Well, they're both a 4th root, and they have all the same insides, right? So then we can combine the number in front. What's 3 plus 7? And then the root doesn't change, so 4th root 11pq. So the only thing that changes is the number in front. Any questions with that? Okay, so let's look at example 4. What does the half power mean? Yeah, it's a square root, okay? Now, these cannot combine because the bases aren't the same. So remember, all the rules that we've been learning, the bases had to be the same. So if these were both x or both 75, we could subtract the exponents, right? Or add, sorry. Well, we're subtracting, never mind. But I'm thinking multiplication. Sorry, y'all. I'm mixing things. Anyways, but they are not. You cannot just subtract this because they have the same exponent. Okay? So we're going to put them in radical form. So this is a square root of 75 to the first power, which you don't have to label. Don't forget your minus. And this is the square root of 147 to the first power, which again, you don't have to label. Are they the same radical? No, so can we combine them? No, so we have to break them down and see if they simplify. What goes into 75? So 3 and 25. And then 25 is 5 and 5. Any questions with that? Okay, so what do I get to take out? The 5 because they match. And what goes back inside the square root? 3. I'm going to bring down the minus so I don't forget to subtract. And what goes into 147? This isn't one that I just know off the top of my head. I know 2 doesn't go into it. We can try 3. So 3 and 49. And 49 is a perfect square of what? 7 and 7. Well, what do I take out? And what goes back in my root? 3. Now can I combine them? Yeah, they both have a square root 3. So what's 5 minus 7? Negative 2, and then the root 3, square root of 3 stays the same. Any questions with that? Okay, so let's look at example 5. So now we're throwing in some multiplication and addition. So we have to distribute. So we have the square root of 3 times the square root of 5. Well, this is inside, this is outside, so they just go next door to each other. Plus square root of 3 times the square root of 30, which are both inside. So what's 3 times 30? 90. Okay, well, 5 square root of 3 does not simplify because 3 is prime. But does 90? Yeah. What goes into 90? 3 and 30. Does 3 go into 30? How many times? 10, and then 2 and 5. So what do I get to take out? And what goes back in my house? 10, because we have a 2 and a 5. Can these combine? No. So there's your answer. They are not like terms, so they cannot combine, because what's inside my square root is different. Okay, so flip to the back when you're done writing that down. Okay, example 6. We are multiplying. They're both square roots, so we can combine the insides. There's no plus or minus, so it's not anything we can't do. What's 5 times 2? Now, do they have the same letter? No. So what letter should I put first? X cubed, then what? Yes, because we want them alphabetically. Now, this is a square root. Does 10 break down to 2 and 5, right? Does anything get to come out? No. So the 10 stays in the house, y'all. Now remember, it's a square root when it's not labeled. Does 2 go into 3?
Yes.
How many times? Once, with how many remaining? Does 2 go into 2? How many times? With how many remaining? So there is your answer. Any questions with that one? Okay, so look at example 7. What does example 7 tell me? No. You're close, so power to a power is what we would have done. But because I have a plus sign, we can't follow that rule anymore. So if I had something like 2x squared, then I would give it to the x and I would give it to the 2, right? I would distribute the exponent in. But I can't do that here because I have that plus sign. So I'm going to cross out my squared and I'm going to write it a second time, because isn't that what squared means? So I have to double distribute this. Yes, or FOIL, whatever you use. So 4 times 4 is what? 4 times 3 root 6. Well, outside numbers multiply. What's 4 times 3? And there was no other root to change the 6, so it's just 6. Same concept, 3 root 6 times 4. Well, 3 times 4 is 12, and then the root 6 gets brought down. And then 3 root 6 times 3 root 6. Well, what's 3 times 3? 9. And then what's 6 times 6? 36. Okay, so right away, I see that these two are like terms. Okay, what else do you notice? Are any of these perfect squares? What's the square root of 36? 6. So I can rewrite this as 9 times 6. Well, what is 9 times 6? 54. So this just equaled 54. Now, if you ever know it's a perfect square, you can actually type it in your calculator. So 9 square root of 36, did it also give me 54? Yeah, so if you know it's a square root, a perfect square, you could type it in your calculator. Even if you don't know, but if it gives you a decimal, you'll have to do it by hand, yes? Okay. So what are my other like terms? Well, I know those two already were. Yeah, 16 and 54 are like terms now. So what's 16 plus 54? You always want to do your numbers without the radical first. And then what's 12 plus 12? Root 6. And 6 does not break down because it's just 2 and 3 and nothing matches. So this is your answer. No, because this has a root 6 and this doesn't. They are not like terms. Does that make sense? Okay. Okay, so look at example 8. Same thing, just not the same this time. So square root of 2 times square root of 8. What's 2 times 8? They're both inside. 16. Square root of 2 times negative 5. Well, positive times a negative is a negative. It's going to be 5 square root of 2. Because this is an inside and this is an outside, and those can't combine. 3 times the square root of 8 is just 3 square root of 8. And 3 times negative 5 is negative 15. And those didn't have a house, so there is no house. Yes? Okay. Now, do any of these simplify? Do any of them not simplify? Well, I know 15 can't change, right? That's just minus 15. 2 is prime, so I know this also doesn't simplify. So I'm going to go ahead and just bring those two down. So I still have 2 missing pieces, and we'll work those down too. What's the square root of 16? 4. It's a perfect square. Now, is 8 a perfect square? No. So we have to break it down. 8 is 2 and 4, which is then 2 and 2. Now, I already had a 3 there, correct? So I can't forget about that 3. What am I going to take out? 2. And what has to go back in the house? So what's 3 times 2? Now that I have everything simplified, what combines? What are my like terms? 4 minus 15 are like terms. What does that give me? Negative 11. And then I have, both of these have a square root of 2, so these are also like terms. What's negative 5 plus 6? Positive 1 root 2. Now, I do want you to realize that this answer could also be written like this, without the 1 in front of my square root of 2. So both of those would be acceptable. Any questions with that? Okay, so last one. Same thing. Now, one thing I do want to mention is that technically you could simplify 50 and you could simplify 27, okay? But if you multiply after that, which you would, because we have to double distribute, you might have to simplify again. Do you really want to simplify more than one time? And that's why I like to multiply before I simplify. Yes? Okay. So square root of 50 times square root of 2. Well, what's 50 times 2? Positive times a negative is what's next. This positive times a negative, so this is going to be minus. You're exactly right. 50 times 6 is 300. Then we have a positive times a positive. So positive square root of 27 times 2, which is 54. And then we have a positive times a negative, so minus the square root of 162. All of these have to be simplified, yes? Okay, are any of them perfect squares? What is the square root of 100? 10. Bring down my minus sign so I don't forget. Now, 300 is this. 3 goes into that 100 times. Now, isn't 100 a perfect square? So y'all, if they match, you can stop. Now, if you did like 2 and 50, and then 2 and 25, and then 5 and 5, wouldn't you have a 2 and a 5? What's 2 times 5? So would you get the same answer? Yeah, so if you don't notice it's a perfect square, you keep going, you're going to get the same answer. So it's going to be minus 10 root 3. Then we have 54. 2 goes into 54 27 times. 3 and 9. 3 and 3. So we have a 3 that matches. And what's going to go back in my house? Which gives me, yes, y'all are exactly right. So bring down my minus, bless you. 162 is 2 and 81. Well, isn't 81 a perfect square? 9 and 9. So we can stop, and it's 9 root 2. Do any of those combine? No, because none of them have the same root. So there's your answer. Okay, before you flip to the practice, I do want to talk about one thing. So if you look right here, I'm going to do a couple examples. If you have the square root of 2 plus the square root of 2, what does that equal?
2.
You're exactly right, 2 square root of 2. Because you can put an invisible 1 in front of both of these, right? And 1 plus 1 is 2, correct? Okay. What if you have negative square root of 2 minus square root of 2? Yes, this time it's just negative 2 square root of 2. Because you can have those invisible ones, yes? Okay, what if you have negative square root of 2 plus square root of 2?
0.
It's 0. They cancel. When you have something that matches and one's negative and one's positive, that zeroes out. Yes? The issue is that a lot of people will tell me this one equals 0. 2 negatives will never create 0. Think about borrowing money. If you borrowed money from somebody and then you borrowed more money, is there any way you owe them $0? No, you owe them more. Okay? Negatives do not create 0. Does that make sense? Okay, so be super careful with that. Okay, so flip to your practice really fast.